Hey, Algebra 2, I thought I'd help you out with number 9 on Algebra Practice 41 because it's a word problem and a lot of people get very intimidated by word problems. And because this has a lot of parts to it. It's got A, B, C, D, E. It's got 5 parts that we need to do. So the first thing says determine whether the graph opens upwards or downwards. Well, that one's simple. So it says a football kick is modeled by this function that height, which is h, in terms of x, is going to be negative 0.0075x squared plus 0.5x plus 5, where h is the height and x is the horizontal distance in feet that the ball travels. Find the maximum height of the ball to the nearest foot. So all we have to do to figure out whether it opens upwards or downwards is look at the number, the value in front of the a term. So is that a positive or negative? Since it's a negative, we know it's going to go downward because the general form goes upwards, which means that the negative form will go downwards. You can also think about it this way, is it would go upwards if it was just positive because x squared numbers get bigger and bigger and bigger and bigger. 5 squared is bigger than 4 squared. So then 10 squared is going to even be bigger, and 20 squared is going to even be bigger. So it's going to go up and up and up and up and up. Whereas if you're talking about negative, then it would be negative 10 squared, and then negative 20 squared. So it's going to go down, 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 down. So in this case, it opens upwards. So A, just say upwards, just up. Now for B, it says find the axis of symmetry. The axis of symmetry can be found in a number of different ways. Remember what that means is that if we have either that or that, the axis of symmetry is right down the center. Because symmetry means symmetrical, it's the same on both sides. So we're trying to figure out where is it the same on both sides. Alright, so the simple formula for that is that x is going to be negative b over 2a. Notice that this is the front half basically of the quadratic formula, just a little connection there for you. So it's going to be negative 0.5 over 2 times negative 0.0075. That's something we're definitely going to have to type in our calculators here. Alright, so what we get when we type that in your calculator is approximately 33.3 continued. It's actually exactly 33.3 continued. So that's going to tell us our axis of symmetry, which is the x value. And remember that your axis of symmetry is always on your vertex. So we've actually found half of the vertex value as well. Alright, so we have the x is 33 1/3. So we have to plug that in order to find the y value of the vertex for number C, letter C. So let's plug that in. We get negative 0.0075 times 33.3 continued squared plus 0.5 times 33.3 continued plus 5. Alright, so let's plug that into our calculators now. Remember when you're doing this that you have to do negative 30, or you have to do 33.3333333 squared first, because the order of operations says that you have to find the exponents before you can even start multiplying, dividing, adding, or subtracting. So then this becomes negative 8.3333333 continued plus 16.6666666666666 continued on forever. And then we still have that plus 5. So this gives us, we'll combine these two first. We have, this is going to be negative 8.33 plus 16.66 gives us 8.33333 continued plus 5. That's going to be 13.333333333 continued. And so now that's our y value. So we say that our vertex is at 33.3 continued, comma, 13.3 continued. That's our vertex. Alright, but we're not done yet because that is C, find the vertex. Now D says find the y-intercept. Oh, well the nice thing is that that's easy. If you think about the y-intercept of any line, that's where it's going to touch the y line. So let's say it's going to look something like this. Where it touches the y line here is where x is 0. So you can go back in here and plug in zeros in this original equation. Which is why you end up with the pattern that this, if you do that times 0 squared, you get 0. 0.5 times 0, you get 0. So you end up with 0 plus 0 plus 5. So actually that pattern shows that your y-intercept is always whatever does not have an x in front of it. Because you now have to multiply that part by 0. So that one's easy. Our y-intercept is just 5. So for part D, put it in black, our answer is just the y-intercept is when x is equal to 5. Or I'm sorry, when y is equal to 5, when f of x equals to 5. Alright, and now E, we actually have to graph it for real. I just sketched it very vaguely a second ago, but we're going to have to do something for real this time. That's alright, because it's already asked us to get all the points that we need in order to graph this effectively. So let's set up, sorry, I don't know what just happened there. Let's set up our y, our x and our y axes here. And I kind of set it up like this because I know that the vertex is at 1333, so or 3313. So I know it's going to be mostly positive numbers that we're dealing with. So we're going to go to, we can just kind of estimate on this. So there's 10, 20, 30, 40. So 33 and a third is somewhere around here. Let's say about right there. So that we know we're going to have to go up from there. And then 13 and a third, that's going to be, let's say we go by 5s. 5, 10, 15. That's going to be around here. Alright, so there's our vertex. And we already know that it's concave down. And we also know, so we know it's going to go down from here. We just don't know how exactly. So let me erase that. Alright, and let me erase these lines so we don't get confused. Alright, so there's our vertex point. And from there, we can also put in our y-intercept, which is 5 right there. Which means we can go all the way on the other side. We know it's also going to be 5 on this side because this is our axis of symmetry. We just figured that out too. So we know it's got to be the same distance on either side. And honestly, that's all we really need to have an effective graph of your quadratic function here. We've figured out that it's going to go, like this. We already knew it was concave downwards. Put a little arrows there to know that it goes on forever. And that's the basic function. And that makes sense. The football gets thrown right here. I'm going to trace with the blue line. The football gets thrown right here. Goes up and up and up and up and up, and then it goes down, 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 down. And it really stops there when it hits the ground. Okay. Now the last thing this asks us to do is find the maximum height of the ball. But we've actually found the vertex, and the vertex is going to be where the maximum height is. Right up there. So we just have to figure out which one's height, the x or the y. Well, let's go back to our original equation here. And we see that we have h of x, so this is the height, is equal to all of this where x is the distance. So it's asking us what's the maximum height, so that means we're finding out what y is, which is the same as h of x. So we figured out at the vertex, the y was 13.3 continued. So we can say, to answer this question, that the maximum height is